Hello everyone and welcome once again to my channel. This time we are going to be having the chemistry series for those that will be writing the forthcoming UBTH entrance examination. So without wasting much time, let's dive into looking at the questions on the board. Question 1. Which of the following is needed to produce a slag during the extraction of iron in the blast furnace? Which of the following is needed to produce a slag during the extraction of iron in a blast furnace? The first thing that should come to our minds should be, what's a slag? Now the slag is actually what is being used to removing the main impurity during the extraction of iron in a blast furnace. So the main impurity that is obtained during the extraction of iron is silica, which is SiO2. So there is something that is much needed to be added as a raw material in order to removing the main impurity that is obtained during the extraction of iron, which is silica. So what is the substance that is needed to be added as a raw material? The substance is limestone, which is calcium carbonate, CaCO3. Now, when calcium carbonate is added, firstly, it decomposes to form CaO plus CO2. Then secondly, the CaO, which is calcium oxide, would now interact with the silica, which is the main impurity in the blast furnace. And when that happens, it will now give rise to the second reaction, which is this. And we are going to obtain CaSiO3. CaSiO3. All right. So this is known as calcium silicate, which is also called slag. So then it can easily be removed from the blast furnace. So it means that the raw material that is of relevance during the extraction of iron from the blast furnace that can be used to removing the main impurity in order to form slag is known as calcium carbonate. All right. So the correct answer is option B, because CaCO3 is also called limestone. So take note of that. Then let's see question 2. Which of the following halogens is the most reactive? This question is a very easy question. Why? Now, all of the members here written in the options, they are members of halogens. And what are halogens? They are the group 7 elements, also called the salt formers. So if you are moving from top to bottom, you should be having fluorine, chlorine, bromine, iodine, and astatine. Now these two, they are gases at room temperature. This is liquid at room temperature, while these two, they are solids at room temperature. So they are asking for the most reactive amongst the halogens. And of course, the most reactive should be most electronegative, because checking these elements, of course, the most electronegative amongst them is fluorine. So if you are asked in your chemistry lessons that which element is the most electronegative element, the best option to go with is the one that carries fluorine, because fluorine is considered to be the most reactive element so far in the world of chemistry. And of course, being that fluorine is non-metal, then you can also say it is the most reactive non-metal. So amongst them, the most reactive remains fluorine. And like I said, the reactivity of fluorine is due to its high electronegativity. So don't forget that. All right. Then let's see question 3. Which of the following properties increases down a group in the periodic table? Which of the following properties increases down a group in the periodic table? Now, these are periodic properties of elements. Firstly, we have electron affinity, electron affinity, we have ionization energy, we have atomic radius, we have electropositivity, and we have electronegativity. These are periodic properties of elements. Now, one very important thing that you need to know is this: atomic radius and electropositivity, dey dap and the IDG. Ionization energy, electron affinity and electronegativity, dey ap and DDG. What does that mean? It means that among these properties, don't be confused. Among these properties are enlisted, only two, dap, and dap stands for decreases across the period and then increases down the group. Then the others, they increase across the period and they decrease down the group. So it's that easy. Now, to the question, which of the following properties increases down the group? So which one? Of course, it should be IDG, which is increases down the group. So it's either atomic radius or electropositivity. That should be our answer. So let's check the options. Of course, option A is atomic radius. That's our answer, which is correct. Then question 4. Which of the following types of reaction takes place between C2H4 and the halogens? C2H4 and the halogens. Let's see how we can smash that question 4. This is a very cheap question and it's under organic chemistry. C2H4, C2H4 and halogens. Halogens. So the kind of chemical reaction. C2H4 is known as ethene. How did I know that that is ethene? It's very easy. Now, the alkenes, they are known by their general formula CnH2n. So if N represents number of carbon atoms and your N here is 2, then of course 2N should be 2 times 2 in this case, which is 4. So C2H4 is what? Ethene. If you want to draw the structure of ethene, it should be drawn in this pattern because alkenes are known by their carbon to carbon double bonds. So if I'm drawing that, then for halogens, halogens are usually diatomic in nature. They exist as diatomic molecule. So let's just say I want to work with Cl2 as the halogen. So Cl2. I carry out this reaction, I would have to break this bond so that there will be space above each carbons. Then I can fit in my chlorines. So at the end, I'm going to obtain something like this. Cl and Cl. That's talking about the spaces above each carbons. I will just fit in my 2 chlorines. So this compound initially was ethene, but now we are having 2 chlorines here. So you don't call it chlorines, rather you call it chloro. So since you're having 2 carbons forward and backward direction is same stuff, so it becomes 1, 2. So 1, 2, since you're having both chlorines to be on different carbons, so you have to indicate their numbers. So 1, 2, di means 2 chloros. So di, chloro, then ethane. Why? It's not carbon to carbon single bond. So dichloroethane. But this reaction is not really, the name of the compound is not really our bone of contention. What we should be focused on is that there was the involvement of bond breakage. So since there is an involvement of bond breakage, then certainly it is addition reaction. Bonds were broken. That's how you can easily recognize your addition reaction. But most times addition reaction involves bond breakage. Substitution does not involve any bond breakage. That's the reason why the alkanes are known to carry out substitution reaction. They exhibit it. While that of the alkenes and the alkynes, those ones that are known by their carbon to carbon double bonds, alkenes, and carbon to carbon triple bonds, alkynes, they are known to undergo addition reaction. So the correct option to go with in this case is option B, addition reaction. Question 5. If the enthalpy change for the formation of sulfur 6 oxide is -197 kilojoules per mole, which of the following conditions will not increase the yield of sulfur 6 oxide? Now, this question is taking our minds to how well we understand the effect of changes in temperature, pressure, and concentration on a system at equilibrium. Now, if you have not watched my video lesson on chemical equilibrium, talking about the Le Chatelier's principle, do well to watch that video to be of help to you to tackling questions with regards to the one on the board. Now, looking at this, the key words that you shouldn't toy with is enthalpy change. Now, we're given the enthalpy change to be negative 197 kilojoules per mole. And remember that enthalpy change is known as delta H. And any reaction that has its delta H to be a negative value, it suggests that such reaction, the forward reaction of such reaction is exothermic, then while the backward reaction is endothermic. See what I'm trying to say? Let me just give an overview. A plus B to give C plus D. Now, we are having this reaction to be a reversible reaction because of proceeding in two directions, double lines, double arrows. Now, let's say this reaction, we are having our delta H, which is enthalpy change, to be negative 80 kilojoules per mole. Let's just say this is our delta H, our enthalpy change, kilojoules per mole. Now, what it means is that the forward reaction of this particular reaction is exothermic because it is negative here, while automatically the backward will now be endothermic. But if I change this sign to positive, it means that this forward now will now be endothermic, while the backward will be exothermic. That's just the summary of everything. All right. And you are aware that endothermic reactions are favored when there is increase in temperature, while exothermic are favored when there is decrease in temperature. Just have that in your mind. So if the enthalpy change for the formation of sulfur 6 oxide, let's even write the reaction for the formation of sulfur 6 oxide. Now, sulfur 4 oxide will have to be bound in oxygen in order to produce sulfur 6 oxide SO3. Balancing the reaction, you should be having something like this. So this is our sulfur 6 oxide, which is our main focus. Now, our delta H is given to be negative 197 kilojoules per mole. So what it implies from what I've explained there is that the forward reaction here would now be what? Exothermic, while the backward will be endothermic. And remember, I said endo is favored by an increase in temperature, exo is favored by a decrease in temperature. Since they mention of enthalpy change, so you should just pay attention to the options that are carrying temperature. Then they said which of the following conditions will not increase, meaning will not favor the formation of sulfur 6 oxide. Since we are having sulfur 6 oxide here, what they are asking us is the one that would not favor the exothermic reaction. And what would not favor exothermic? Will it be decrease in temperature? No. So it's when you now increase temperature that it would now dislike it. So it means that what would not favor exothermic reaction is what they are interested in. And of course, what cannot favor this exothermic reaction, meaning the formation of this? Since the forward reaction is exo and it leads to the formation of this, then what would not favor it is what they are asking. And remember, exothermic decrease in temperature will favor, so it means an increase in temperature would not favor it. That's our answer. So let's check. Increase in temperature is in the option. So this will not increase or favor the yield of sulfur 6 oxide, while the others will favor or increase the yield. So that's how you go about tackling questions like this. I've done a video lesson on that. Just do well to watch my video on chemical equilibrium on this channel, then you understand how to tackle questions with regards to that. Then let's see question 6. Question 6, consider the reaction represented by the equation below. This is the equation. So let me write out the equation. X NH3, I will just neglect the state of matter, Cl2, then Y, then to produce ZHCl and DN2. So how do we balance this? Let me just remove all this, not to interfere. How do we balance this reaction? How many N is here? 1N. Over here is 2. So we can just balance this by putting 2 here. Now it becomes 2N and 2N. N is now balanced. Then next, these 2 will affect the hydrogen here. So how many hydrogens are here now? 6, because 2 times 3, you have to multiply, you don't add. So 2 times 3 is what? 6. How many hydrogens are here? It's just 1. So you have to make here 6. Then next, we're having 2 chlorines here, but over here is 6. So what do we multiply by 2 to get 6? 3. So everything becomes balanced. So remember that if we want to now introduce those letters written previously, then it should be what? X, Y, and what? Z. So it should be 2, 3, and 6. Remember, there is no D in the question because the question is, it said the values of X, Y, and Z are, so it should be 2, 3, and what? 6. So do we have it there? Yes, option C, 2, 3, and 6. That's our correct answer. Then let's see question 7. Question 7. Which process is involved in the reaction represented by the following equation? And this is the equation. Now, looking at this equation, you would see that indeed this happens to be a salt, and water is being added to the salt. At the end, there was now the formation of base and acid. Now, this question should be taking your mind to hydrolysis of salt. There's something that's called hydrolysis of salt. What does that mean? It means that when a salt, water is added to it, and it wants to cause hydrolysis to this salt, it will form the acid and the base that resulted in the salt formation. So what it means is that, let's say I'm having a salt, NaCl, which is very common, table salt or common salt. If I add water to it and it now ends up giving me NaOH and HCl, which is a base and an acid, then it's obvious that this is known as hydrolysis because water came in the form of HOH and then attacked the parts of the salt. This is positive, this is negative, this is positive, and this is negative. So the unlike charges will attract. This will now give us HCl, while this will attract this to form NaOH. So the basic thing about hydrolysis is that when you add water to a substance and it causes the splitting of the substance, then of course that's known as hydrolysis. Just like if I have substance AB and then I added water to it to form AH and BOH. In this case, you can call this hydrolysis. But if I add water to a substance, this same substance, and then it now ends up forming AB.H2O, this is called hydration. So you must know the discrepancy because water did not split this substance. That's why it's called hydration. So this is hydrated compound, while this is an hydrolyzed compound. So the correct option to go with in this case is option B, because option B is hydrolysis. So let's see the next question. Question 8. An element with mass number 133 and atomic number 55 has dash. So before we can look at this, let's get the proton, electron, and neutron number of this element. Firstly, they gave us the mass number to be 133. So it's very easy. Let's say this is the element. So write this is the mass number. So write our mass number 133. Then next, the atomic number is what? 55. So write it beneath 55. Now mass number 133. Then atomic number. Remember that atomic number is also called proton number. So atomic number or proton number is 55. Now, bearing in mind that they didn't say an ion, they said an element. An element. So assuming there was a charge, they would have indicated it. So since there is no charge, remember that the proton number being the atomic number 55 would be the same as the electron number. So the electron number will also be what? 55. So the number of electrons 55, the proton 55. Then what about the neutron? How do we get the neutron? Remember, when you see an expression like this, you are supposed to know that for you to obtain the neutron, you have to subtract the proton or the atomic number from the mass number. So for you to obtain that, it should be 133 minus 55. So with the help of our calculator, 133 minus 55 should give us 78. So 78 becomes the number of neutrons. So the neutrons would be 78. All right. So we now know our proton number electron and neutron number. So let's check the one that will be correct. Option A, 55 electrons, would that be correct? First, yes. Then 55 neutrons, no. We have 78 neutrons, so this will be wrong. Then B, 55 electrons, correct. Then 78 neutrons, yes. So this becomes our answer. Let's check option C. 78 electrons, wrong, already wrong. 78 electrons again, very wrong. So we have 55 electrons. So the best option to go with in that case is option B. Then question 9. An element X has electronic configuration, and the electronic configuration is given as 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So they are asking that to which group of the periodic table does X belong? This is very easy. Now the trick is any element whose orbital configuration ends in s, because in this case this is 4s, irrespective of the number coming before the s, so long it ends in the s, just know that anything written as the power is the group. So in this case, since it ended in 4s2, then it means that the power of s is 2. Automatically, that is the group. So any that ends in the s orbital, the power becomes the group, while the coefficient, which is number before the orbital, becomes the period. So that's how it works. So in this case, what should be our answer now? Our answer should be group 2. So correct answer option B. Question 10. What is X in the reaction represented by the equation below? And we have been given this equation. This is a typical example of cracking. A large organic molecule is being cracked to releasing smaller fractions. So let's see how we can get what X is. Now this is the reaction. C10H22 being cracked to produce C5H12 plus C2H4 plus X. Now it's obvious that this is a total of 10 carbons. We are having 5 carbons and 2. So 5 plus 2 is 7, so we should be left with 3. So it means 3 carbons. We are trying to get the last product being the X there. Then what about hydrogens? Hydrogens here is total of 22. When cracked, we had 12. So 12 plus 4 is what? 16. Then what should we add to 16 to get 22? We have to add 6. All right. So that's what we are to obtain. So we have obtained the formula of the X. So what is now this formula representing? C3H6. Now alkanes is CnH2n plus 2. Alkenes is CnH2n. Alkynes is CnH2n minus 2. N, remember, represents number of carbons. So which one do you think will make sense? Because this is alkane, this is alkene, and this is alkyne. The one that will make sense automatically should be alkene. Why? C3, if N is 3 here, then it should be what? 2 times 3 in this case to give us 6. So C3H6. So C3H6 in that case is actually a member of the alkenes. Then what member? What particular member? Since we are having 3 carbons, then it should be for what? Prop. So the name should be propene. So it's C3H6. The correct answer should be option C. All right. So let's see the next question. Question 11. Consider the reaction represented by the equation below. And then we are given this equation. This is a typical example of combustion reaction that involves methane being burnt in oxygen to produce CO2 and water. Now they are asking us how many moles of carbon dioxide will be produced from 32 grams of methane. So this is a typical example of stoichiometry. This question is taking our minds to stoichiometry. So let's see how we can tackle this question. Firstly, let's bring out the equation. CH4 methane plus 2O2 oxygen to produce CO2 carbon dioxide and H2O water. So the reaction is balanced. Now what did they say? how many moles? So it means what they are asking us over here is to calculate the number of moles. But meanwhile, you can use the code, which is isolate, convert, and ask. This is my code. So you can do well to watch my video lesson on stoichiometry to be of help to you. It's very easy. All you simply do is just use this principle of isolation, conversion, and asking yourself the question. But mind you, let's start with isolating. What are we isolating? We should isolate what is relevant from what is not relevant. What it means is that we should bring out those things that are of relevance in this reaction, things information have been provided of. Now, consider the reaction represented by the equation, and this is the equation. Carbon 4Z will be produced from 32 grams of methane. Now, carbon 4Z, methane were mentioned. This is methane and this is carbon 4Z. Bring these two out. CH4, that's you are isolating. Then CO2 gas. So these are the two things that you should focus on. Then next, the language of the equation always speaks moles, because now in this case, this is 1 mole of methane to produce 1 mole of carbon dioxide. So what are they asking us? They are asking us that how many moles of carbon dioxide will be produced, meaning X mole of carbon dioxide will be produced from 32 grams of methane. Then what are you supposed to do? You have to convert this into the language of the question, which is the equation in question. You have to convert this to the language of the equation, and the equation is speaking in what? In moles. So what are you supposed to do? You convert 32 grams of methane to moles. And how do you go about it? Firstly, for you to get the number of moles of a substance, you should work with what? Mass of the substance over what? The molar mass. So what's the mass? The mass of methane is provided and it is given as 32 grams. So 32 over, then what's the molar mass? We can get it, CH4. That was the reason why we are provided with all these relative atomic masses of these elements. So for you to get it, it becomes carbon is 12 plus hydrogen is what? 1 times 4, because the 4 is attached to the hydrogen. So it becomes 12 plus 4, which is 16. So it means our molar mass should be 16. To get it, the number of moles now should be 16 into 32. That should give us 2. So it means this should be 2 moles. So they are asking how many moles of CO2 will be produced from 32 grams of methane. And 32 grams of methane is equivalent to 2 moles of methane. So that's what they're asking. So all you simply do is just cross multiply. No need of even cross multiplying. Why? Because 1 mole produces 1 mole, then 2 moles will produce 2 moles. So it's that easy. So becomes your answer. So 2 becomes the right answer. It's that easy. Let's see the next question. Question 12. In a catalyzed reaction, the value of EA is dash. Now we need to understand what EA represents. EA represents activation energy in the reaction. Activation energy, that's EA. Now, we are aware that the activation energy is the minimum amount of energy that is required for a chemical reaction to occur. Now, for a catalyzed reaction, it means that it contains catalyst. And for a catalyzed reaction to proceed, the catalyst in question, for it to increase the reaction rate, it has to lower the activation energy. How does it lower the activation energy? Now, it tends to provide an alternative pathway with a lower activation energy for a chemical reaction to proceed at a very fast rate. Alright, so for a catalyst to increase the reaction rate, it has to reduce or lower the activation energy or the energy barrier. So any catalyzed reaction must be having a lower activation energy because you are having the presence of a catalyst. Then uncatalyzed reactions would be having higher activation energy because of the absence of catalyst. Alright, so in a catalyzed reaction, the value of EA, which is activation energy, is A greater than EA of uncatalyzed reaction, which is wrong, because remember that the presence of a catalyst makes the activation energy to be lowered. Then B equal to the EA of uncatalyzed reaction, which is also wrong. Then C less than the EA of uncatalyzed reaction, which would be the right answer, because when you have a catalyzed reaction, the EA must be lowered, must be less than an uncatalyzed reaction. So option C becomes the best option to go with. Then D, opposite to EA of uncatalyzed reaction, that is wrong. Then question 13. Which of the following compounds has the highest percentage of carbon? How do we go about this? Now, we have to consider all of the compounds written in the reaction. Firstly, C2H2, C2H4, C2H6, and C2H6O. How do we get the percentage composition of carbon in each of these compounds? It will be very easy. Firstly, we have to get the relative molecular weight of each of them. For C2H2, carbon is 12 times 2 is 24. Then hydrogen is 1 times 2 is 2. So 24 plus 2 should be 26. Then over to this. Carbon is 12 times 2 is 24 plus 4, because 4 times 1 is 4. So 24 plus 4 will give 28. Then over to this guy, carbon, which is 12 times 2 is 24, then plus 6 is what, 30. Then carbon here is 12 times 2 24 plus 6 30, then plus 16, that's 46. 46. So let's get the percentage composition of carbon in this compound. Remember, carbon is 12 times 2 is what, 24. So 24 over 26 times 100. Then here should be 24 over 28, which is this, times 100. Then over to this place is 24 over 30 times 100. Then over to this place is 24 over 46 times 100. So with the help of our calculator, we can get the answer easily. Now 24 times 100 divided by 26. This gave 92.3% carbon. Then let's check for the other. 24 times 100 divided by 28. We are to obtain 85.71. Then the next, 24 times 100 divided by 30. We are to obtain 80. 80 over here. Then the last one is 24 times 100 then divided by 46. We are to obtain 52.17. So the one that has the highest is the first one, which is 92.3%. So let's check which one would be the best. Option A is the right answer. All right. So let's see question 14. Question 14 says, when X is heated with manganese oxide, oxygen is produced. X is dash. Then these are the options. Option A, KCl. Option B, KClO3. Option C, CaCO3. Then option D is ZnCO3. Then let's see which of them would be heated with manganese oxide and then oxygen gas will be produced. First and foremost, this question should be taken in our minds to the laboratory preparation of oxygen that determine the composition of a compound. And the compound, of course, is amongst these options, but let's confirm. Now, KCl is heat stable salt. So when heat is applied, this salt is literally stable to heat. Nothing happens. It remains KCl. Then KClO3, when heat is applied and then in presence of manganese oxide, we are to obtain KCl plus O2. Then when you balance the reaction, you are to obtain something like this. All right. So that's a compound. Then for CaCO3, when heat is applied, it gives CaO plus CO2. Then the last, which is ZnCO3, when heat is applied, it produces ZnO plus CO2. So the best one to go with is this guy, because it produces or it yields oxygen gas. So option B becomes the right answer. That's called potassium chlorate, or you could call it potassium triazochlorate 5. All right, so that's the IUPAC name. Then question 15. The oxidation number of manganese in KMnO4 and MnO3 2 minus. Then let's see how we can get our answer to that. This question is a very easy question. Now, they are asking for the oxidation number of manganese in KMnO4 and MnO3 2 minus. This is a compound, while this one is a radical. So being that this is a compound, you equate to what? 0. Being that this is a radical, you equate to the charge on the radical, which is -2. You erase it and equate it to that. That's how you go about it. Then manganese here is unknown. Manganese here should be unknown because that's what we are asked to find. Oxygen in most compounds, the oxidation number is -2. Potassium being a group 1 element is +1. Then oxygen here -2. So what do? Take the algebraic sum, which is 1 plus x, then 4 times -2 is -8, equal to what? 0. 1 minus 8 is what? -7, equal to 0. So when you move 7 to the other side, it becomes x equal to 0 plus 7, which will give us +7. So the oxidation number of manganese here is +7. Then over to this place. Then what are you supposed to do? X 3 times -2 is what? -6, equal to -2. So when you move this -6 to this other side, it becomes x equal to -2 plus 6. -2 plus 6 is what? +4. So the oxidation number of manganese is +7 and +4. So where do you find +7 and +4 among the options? Option C. So option C becomes the right answer to that question. Question 16. The oxidation numbers of oxygen in H2O2 and H2O E/R. Now this question is coming from how well we understand the oxidation number of elements in compounds, in radicals, in simple ionic representations in their free state, especially in the case of oxygen and hydrogen. Now oxygen in most compounds, the oxidation number is -2. Then while that of peroxides is -1. Alright. So looking at this question now, the oxidation numbers of oxygen in H2O2, which is hydrogen peroxide. H2O2 is hydrogen peroxide. That's the formula of hydrogen peroxide. Hydrogen peroxide. And the oxidation number of oxygen here is -1, while in other compounds is -2. So the oxidation numbers of oxygen in this -1, in this -2. So -1, -2, option C is the right answer. Then question 17. Which of the following gases can be collected by the method of downward delivery? Now there is something I would need to explain here. There are methods for collecting gases when they are prepared in a lab. Is that by the delivery method of the gas, or we could actually use the upward displacement or downward displacement of air? Now this is it. When a gas is being collected via downward delivery, it means it's same as upward displacement of air. But when it is collected via upward delivery, it's the same as downward displacement of air. One very important thing that you need to take note of is this, that heavy gases that are heavier than air or denser than air can be best collected via downward delivery. Those that are lighter than air can be best collected via upward delivery. Take note of that. And of course, the standard of air is 28.89 in terms of the molecular mass, while the density is about 14.4 something. All right. So that's that about that. So let's see how we can tackle this question now. Let's get, firstly, we have to get their molecular weight. For that of chlorine, chlorine is the first option, chlorine Cl2. Then should be relative atomic mass of chlorine is 35.5 times 2 should give us 71, which is way higher than our standard air. Remember, air is 28.89. 0.89. So this is way heavier than air or denser than air. Then it should be collected via downward delivery. But let's confirm the others. Then the other option, option B, is oxygen. Oxygen is O2, which is 16 times 2 is 32. Now, oxygen's weight is almost similar to that of air. So the best thing to do is that you can actually collect oxygen by downward displacement of water, because oxygen is slightly soluble in water. All right, so you can use that to collecting oxygen. That's one of the best methods for collecting oxygen in the lab. Then as for ammonia, ammonia is NH3. NH3, nitrogen is 14. 14 plus 3 times 1 is 3. Then that should give us 17. 17 is lighter than air, so it can be best collected via upward delivery or downward displacement of air, which is same stuff. Then we have hydrogen, hydrogen H2, which is very, very light. So it can be best collected via upward delivery. All right. So which is 2 in this case, because 2 times 1 is 2. So the best option to go with is chlorine, which is heavier. Hence, it can be best collected via downward delivery. So that's the correct answer to that question. So let's see the next question, question 18. In question 18, you can pause the video and take down this explanation. Question 18. The percentage of water of crystallization in ZnSO4 dot 7H2O is dash. So what they are interested in that compound is the 7H2O, which is the water of crystallization. But meanwhile, we have to get the relative molecular weight of this compound. And how do we go about it? Now, the relative atomic mass of zinc is 65. So 65 plus sulfur is 32. Oxygen is 16 times 4, 64. Then dot, it becomes 7 times 18, because the relative molecular weight of water is 18. So 7 times 18. Then, of course, we have to obtain the right answer. So let's get this one. With the help of our calculator, 7 times 18 is 126. So it becomes 65 plus 32 plus 64 plus 126. 126. Then we have to get the relative molecular weight of the compound. All right. So plus 65 plus 32 plus 65. That should give us 126 plus 65 plus 32 plus 65, 288. So it gave us 288. Then for we to obtain because they said the percentage of water of crystallization in this. So this is the relative weight of water of crystallization in the compound. And of course, we obtained 126. So it becomes 126 above, then over the entire weight of the substance being 288, then times 100. So let's get the answer to that question. So 12600 then divided by 288. It gave 43.7, approximately 44. Approximately 44%. So the correct option is option B. Then question 19. Which of the following is not a member of the homologous series of the paraffins? This question is a tricky question, but you can get it. Is not a member of the homologous series of the paraffins. What are paraffins? Now, the paraffins are the alkanes. The alkanes. And remember that the general formula of the alkanes is CnH2n plus 2. All right. So looking at this, let's confirm whether that will be a member. Already N, remember, it represents number of carbon atoms. So let's see. Our number of carbons is 3 here, so it becomes C3H2 times 3 plus 2. 2 times 3 is 6. 6 plus 2 is what? 8. So all we have to do is any number we are having here, we have to multiply by 2 and add 2 to see whether we have to get this. If we don't get it, then it is wrong. So let's confirm. 5 times 2 is 10 plus 2, 12. which is correct. Then 15 times 2 is 30, then plus 2, 32, which is correct. Then let's confirm. 24 times 2 is 48, plus 2 should be what? 50. But is this 50? No. So hence the correct answer is this. This is not a member of the paraffins. Is that easy? Then let's see question 20, being the last question. I'll have to create more space for this question because that question is taking our minds to gas laws. And what gas law is taking our mind to the Graham's law of diffusion. Now, once say Graham's law of diffusion, the rate of diffusion or effusion of a gas is inversely proportional to the square root of its vapor density. All right. Then, of course, you should be having something like this as a representative or representation. Rate inversely proportional to square root of vapor density. And you know that the vapor density of a gas is actually uh, twice of it forms what is known as the molecular mass. So for you to obtain the molecular mass of a gas, you have to multiply the vapor density by 2. And I guess you must have seen something like this as an expression, not to waste much time. Then you have molar mass 2 over molar mass 1 equal to then d2 over d1 then is equal to we have T2 over T1. So all these represents the formula for Graham's law of diffusion. All right. So let's see how we can go about this question. If 25 cm cube of oxygen diffuses from a certain apparatus in 10 seconds, calculate the volume of nitrogen which diffuses from it in 15 seconds under the same conditions. So we are having nitrogen and we are having oxygen, but we are given the volume of oxygen and we are told the time it took to diffuse. So firstly, we have to know that rate is equal to volume over time. So for you to get the rate of diffusion of oxygen gas, the volume is given to be 25, then over, then what about the time? The time is 10 seconds. So when you divide this, you have to obtain 2.5. So this will be the rate of diffusion of oxygen gas. The rate of diffusion of oxygen gas. So do we know the rate of diffusion of nitrogen? Not yet. We are told to calculate the volume and then we are given the time. So what do we do? Firstly, let's say our 1 represents O2 and our 2 in this expression represents N2. So what are we supposed to do? Let's just pick these first two parts and then work with it. In order to obtain the rate, let's get the rate of diffusion of nitrogen before we can get the volume. And of course, for you to do that, 1 represents oxygen and 2 represents nitrogen. So let's go. The rate of diffusion of oxygen will be R01. So R01 would be equal to what? 2.5. Then what about the M1, which is that of molar mass of oxygen gas, would be what? Would be 32, being that 16 times 2 is 32. Then R02, which is that of nitrogen, is unknown. Then M2, which is that of nitrogen, would be 14 times 2, which is 28. So that's how we go about it. Then let's plunge it into this formula. That becomes R01 over R02. That's the formula we are working with. Root M2 over M1. What's our R01? Our R01 is 2.5 over, what's our R02? Unknown. Then what's our M2? Our M2 is the molar mass of nitrogen, which is 28 over, what's our M1? Our M1 is 32. So we can even do this by simply taking the square of both sides. So we cancel out. Then we can get the square of that. Now the square of 2.5, 2.5 times 2.5 should give us 6.25. So this is 6.25 then over x square then equal to what? 28 over 32. When we cross multiply, we have to obtain what? We have to obtain 28x square equal to 6.25 times 32. So we can even simply just divide by 28. By 28. Alright, so that gives us what? X square equal to, let's just use our calculator on that. 6.25 times 32 then divided by 28. 7.14. Then when we took the square root of that, we got 2.67. But we initially obtained 7.14, but we have to take the square root of both sides in order to get x. And when you do that, it becomes what? 2.67 as our x. That's the rate of diffusion of nitrogen. Then next, since we know the rate of diffusion of nitrogen, what we need to calculate the volume. The rate of diffusion of nitrogen, which is N2, equal to what? Volume over time. What did we get as the rate? We got 2.67. So 2.67, which is the rate, equal to volume is unknown. That's what we are told to find. Then what's the time? The time is 15 seconds over 15. So we can easily get the answer now. All we simply do is just to multiply 2.67 times 15. Then we'll get the answer to that. So the answer is 40.05. Approximately what? 40.1, because we got 40.05. When you round this off to this, it gives what? It gives 40.1 cm cube. So the correct answer is option A. So it's that easy. There are shortcuts to this, but you can as well use this method and you'll be fast about it. You'll be able to get your answer with ease. So we have come to the end of this series. And I wish you guys all the best. For those that are preparing to write in the forthcoming UBTH entrance examination, you are coming out with outstanding results and flying colors. Alright. So if you are yet to be a subscriber of this channel, do well to hit the subscribe button, and you should also share this video to your friends too. Don't forget to turn on that notification bell by the side of the subscribe button in order for you to be the first to be notified whenever I drop exciting content. If you find this video helpful, give that thumbs up button, which is the like button, and then don't forget to be a subscriber because more are yet to come. I wish you guys success ahead. Thanks for watching.